Hello, this is video 2 for Chapter 9, STA2023 Statistical Methods. So we're going to do another example. It is reported that the average body temperature of all healthy humans is 98.6 degrees Fahrenheit. Here is a sample of 10 healthy humans. So in this case, we have data. 98.5, 98.2, 99, 96.3, 98.3, 98.7, 97.2, 99.1, 98.7, and 97.2. Is there enough evidence at the 10% level that the average temperature for a healthy human is not equal to 98.6 degrees? So in this case, we're dealing with numbers, 98.6 degrees. We have one group, so we'll be doing a t-test. So since we have data, I'm going to go to the calculator, and we're going to put our data in. So if you remember, we go to Stat, number 1 for edit, and I put my data in list 1. Again, double, triple check your numbers. If one number is wrong, it will not work. Second mode, go back to the home screen. So our mu is 98.6, that's given. Our x bar we're going to get from the calculator. So stat, calculate, one variable statistics for list 1. And our x bar is 98.12. Our standard deviation, which is S, is 0.9187. Sample size is 10. And our alpha is 0.10. Okay, so our HO is mu equals 98.6. The average body temperature for healthy humans is equal to 98.6 degrees Fahrenheit. Mu is not equal to, from the problem, not equal to 98.6. The average body temperature for healthy humans is not equal to 98.6. We're going to check our conditions. Is it random? Yes, it's stated. Normal has to be greater than 25. In this case, it's not. But if we make a histogram on the calculator, to remind you of that, we go to second y equals, go into plot 1, turn it on, choose histogram of list 1, move it up, zoom 9. That's what the histogram would look like. It's not symmetric, it's actually skewed to the left, but we're going to assume it's normal so we can move on. Again, before we move on, make sure you turn that plot off. Okay. And population has to be greater than 10 times the sample size. So our population is all healthy humans. Is that greater than 10 times 10, which is 100? Check. So we passed our conditions. Again, we assumed because it was under 25. Move on. Now, to find our SE, it's the standard deviation, 0.9187 divided by the square root of n, which is 10. You get 0.2905. To find our t, it's 98.12 minus 98.6 divided by 0.2905, which gives us negative 1.65, which would be about here. But because we're doing not equal to, we have to check both sides. So we have negative 1.65 and positive 1.65. This would be the p-value, these two shaded areas. Negative 1.65 to the left, positive 1.65 to the right. That is a picture of our p-value. Now we're going to compare it critical values to the t-star. Now remember, for t-star, it's 90% is what's given because alpha is 10, and degrees of freedom is n minus 1. 10 minus 1 is 9. We're going to go to the table to look up 1 point and make sure we get 1.833. Okay, so at the table, we look up 90 and 9, and that gives us 1.833. 90 and 9, 1.833. Okay, now if we do a picture of our t-star, 1.833 would be to the right of 1.65, and negative 1.833 would be to the left of negative 1.65. That area, those two areas combined, would be our alpha. So our p-value is greater than our alpha, so we do not reject. But we can also compare our p-value to our alpha, but we get the p-value from the calculator. So I go to the calculator, we go to Stat, Tests, number 2 for t-test. This time we're going to choose data. Our mu is 98.6. Our data is in list 1. Don't mess with frequency. Choose not equal to, and you can go to draw. And this will give us a very similar picture to what we drew, a picture of our p-value. And again, it's shaded on both sides because it's not equal to. We got t of negative 1.65. They give a t of negative 1.65 as well, with a p-value of 0.1329. 0.1329. So that's where the p-value came from. Our p-value is not smaller than alpha. So we do not reject HO. There is not statistically significant evidence to reject HO. we conclude that the average body temperature for healthy humans is not different than 98.6. So the claim was 98.6. We were saying it's not equal to 98.6. We're saying it's not different than 98.6 based on our evidence. Now, we're going to do our confidence interval, but remember, it's not different than 98.6. So for our confidence interval, it's x bar, 98.12, plus or minus t star, 1.833, times our SE, 0.2905, gives us 97.59 and 98.65. Notice the claim was 98.6, which is in the interval. That's why we could not reject it. So we are 90% confident the average body temperature for healthy humans is between 97.59 degrees Fahrenheit to 98.65 degrees Fahrenheit. All of the steps are located here in your notes, step by step by step.